Hey folks, I thought I'd put this together for you to try and help you through the colligative properties worksheet, which is really just focused on calculating the boiling point elevation or the freezing point depression that occurs when you take a pure solvent and make a solution. We mentioned in class that the elevation, the change in the boiling point, is correlated to the concentration. It's a direct relationship. The higher the concentration, the greater the change in the boiling point. And similarly, the higher the concentration, the greater the change in freezing point. That's most easily shown in the formula that we use for calculating. And so the change in the boiling point, delta T, that's the change in the boiling point or the freezing point, is going to be equal to some constant of proportionality that most texts refer to as KB, okay, for boiling point, or KF for freezing point, and that's multiplied by the molality of the solution, okay? Now, if we want to do this, let's look at number 1 on the worksheet, okay? In number 1 on the worksheet, you have 11.4 grams of ammonia. So I'm just going to change colors here. So 11.4 grams of ammonia. Okay. And that's dissolved in 200. Okay, and I put the little decimal point here to give me 3 significant digits. 200 grams of water. Okay. And they want to know what's the boiling point elevation, how much is the boiling point for water changed by the addition of this much ammonia. Okay, so let's fill in the pieces. We want to know delta T. Okay, that's easy enough. They give me KB in the context of the problem. They tell me that the boiling point constant is 0.52 degrees Celsius per molal. Okay, so then I've got to figure out the molality, so I can put that in here. So to do that, I want to make sure that I convert the amount of ammonia to moles. Okay, so if I take 11.4 grams of ammonia divided by the molar mass, I should get 0.669 moles of ammonia. So that's going to go in the numerator. And then we want to put the mass of the solvent, water in this case, in kilograms in the denominator. So 0.200 kilograms. Okay. If I finish out that multiplication, I can see that the change in temperature, or the change in the boiling point for water for this new solution is 1.7 degrees Celsius. Okay, so in other words, the new boiling point for this solution, if the boiling point for water is 100 degrees, the new boiling point for this solution would start at 101.7 degrees Celsius. Okay, boiling point elevation causes it to go up. I figured I'd work out one for you in terms of freezing point depression. So let me slide in here, and let's put our formula back up. Let's do number 11 on the worksheet. Okay, it's really the same formula. The only thing that's different is we use the freezing point constant. Okay, in number 11, we're taking, and we want to know how many grams of silver, so a little different shape to this problem. How many grams of silver need to be dissolved to cause the freezing point to change by 0.25 degrees Celsius, okay? So they tell us that the change in freezing point is 0.25 degrees Celsius, okay? Again, they give us the freezing point constant in the context of the problem. That's 1.99 degrees Celsius per molal. And so we're going to want to solve for the molality. okay, and actually really just the moles of silver. Okay, and we have 1.12 kilograms of ethanol. That's given to us in the problem. Okay, if I solve that out, I get 0.15 moles of silver. Okay, that's, well, you know what you end up getting here. Right, if I convert that to grams by multiplying by the molar mass, I should get about 16 grams. Okay, hope that helps.